So in this problem, we have another data table, right? It's not a big one, but I've got a data table right here. And we've got a paragraph above it, which is a lot of words. And if you're in a hurry in a standardized test, remember, when you have a data table, you can usually safely assume that all the words above the table just describe the table. Maybe give you a little bit of a story about it or something. But in this case, it says, we have this engineering project and the students are measuring a car, and it goes a distance of x in a time of t. Okay, and it just describes the table. So you've got t here. This is time. And you've got x over here. That's your distance. And if you've been lucky enough to take physics, then you'll enjoy this problem. But this is a basic style of algebra where you have to take a story and you have to put it into an equation describing that story. So in this case, it wants to know which of the following equations represents the data collected. And you can see all these equations are x equals. So they want to have some kind of an equation where if you plug in the various t's, 0, 1, 2, 3, 4, you get the correct answer for x, 11, 16, 21, 26, and so on. So I'm not sure what the quickest way to do it is, but you can just start plugging in numbers here. If you plug in 0 for t, that might be a good place to start. Plug in 0 for t, what do you get? I hope I get 11. So let's try this first one. If you plug in 0 here, you're going to get 0 plus 11 equals 11. Great, that works. How about the next one? Well, 5 times 0 plus 11. That's also 11. But all these other ones, those aren't going to work, right? 16 times 0, that's just 0. That's no good. 11 times 0 plus 5 equals 5. That's no good. And 5 times 0 plus 6 equals 6. That's no good. So right away, I've got 3 answers that aren't going to work right here. And that's great because we've narrowed down our list substantially. For a very easy trick, all we did was we plugged in 0. That's one of the nice things about 0. It's very easy to plug in. And now if you plug in 1, you can try another one of these things. So let's plug in 1 now. I'm going to erase. Whoa, that's not what I wanted. I want to erase this stuff. And now I'm going to try plugging in the number 1, t equals 1. So 1 plus 11, that's equal to 12. I wanted 16 in my table. So that one's not going to work. And we have our answer right here. You can double check it. 5 times 1 is 5, plus 11 is 16. So that's one method of solving this, which is just plug stuff in and see if it works. And it's not a bad method. If you're interested, you can try another technique, which is more like building the equation in the first place, not just by testing the equations below, but by actually building it. So if you look at the data table, what we have here is a starting point of 11, right? This is where the little car starts. And you can see, what does it go each second? Each second it looks like it's hopping or traveling a distance of 5. So if you think about this in terms of an arithmetic sequence, maybe that will be helpful if you learned about them, but it's not necessary. What this means is, if my time is t, I multiply it by 5 to represent these little jumps right here. Every second I jump another 5 distances, whatever I don't know what the units are. Do we know? Feet. I jump 5 feet every second. So that's going to be 5t. And then you have your starting point there of 11. That's time 0. So if you think about it in terms of building an equation, that might be a helpful way to look at it. And there's your equation right there. But you could also just plug things in. It's just a preference.